So here's another example of Poncelet transverse using departing from an outer circle, from a blue point here somewhere on this outer circle, and then utilizing either one of these two internal caustics, the red and the green one, in alternating fashion. Now these two caustics are identical circles, where the green one is a rigid rotation of the red one by 45 degrees about the center, O1, of the black one. So what I'm going to do here is I'm going to start drawing these rays that are tangent to these two caustics in alternating fashion. And I've set them up in such a way that after 10 iterations, I'm back to P1. Okay, so I've done this sort of numerically and almost manually. Now you can see here that I'm reporting the distance between the original P1 and where this 10-step iteration winds up. So it's going to wind up at a vertex here that is, whose distance is being reported here, and it's actually being reported as 10 to the minus 9. This is actually the square of the Euclidean distance between P1 and the 11th vertex on this polygon. Now what I'm going to do now is I'm going to rotate it, okay? And what I want to know is if that error is actually changing or becoming, much bigger. And I can see that the error, as I rotate between P1 and P11, is actually remaining in the 10 to the minus 9 zone, which means that, at least numerically, this suggests that the porism is maintained. In fact, there's even like some locations where the error goes to 0. Okay? So this could suggest that in the setup, the porism is being maintained. And I'm just going to run this a little bit here so that we can observe it. And I'll just leave you guys with the thought that these two caustics are obviously not in the same pencil as the pencil defined by the black or the red, or the black and the green. Okay. Now the thinking behind this is, could there be a compatible map that is being enacted by a tangency from the black to the green and from the black to the red? Meaning, are they operating in a compatible manner? I'm thinking here translation shifts, either in the argument of a Jacobi elliptic function, or as a translation on superposed elliptic curves, if you will. The fact remains that there is some rational division of the period taking place here. These things are working for any position of P1, so this seems to suggest that there is either an accident or there's something singular about this phenomenon. Okay, so I'll see you on the next video.